Howdy folks, my name is Doug. Welcome to my shop. In this video I'm going to be making some measurements, showing what the problem is, and hopefully starting down the path of adapting the tailstock that I got with this Logan lathe to the Logan lathe, since it's obviously the wrong tailstock. As I explained in the video, it's unlikely I can replace the tailstock at a reasonable cost, so I'll be making some adapters. This will start a series of videos. It may take a few months to get them all made, because to get the adapters made, because I may need to get more equipment into service, and just difficulties figuring out how to do all this stuff. But I think it'll be worth it in the end, because a lathe without a tailstock's got a lot of limitations. I do have a working tailstock on my other lathe, the Enco lathe, but the Enco lathe is got some issues of its own. They're probably a little more minor, but those will also be taking up my time while I'm working on all of these projects. Thanks for watching. Hope you keep watching later. Here on the Logan, there is a bit of a taper here in the entrance to the spindle. Don't know if that taper, don't believe it matches any of the standard tapers like MT5, MT6 or something. The Enco's an MT5, but it won't fit a standard MT5 center, for instance. I'll do a whole video on that later. But you have to get an adapter, and it's a standard adapter. For whatever reason, wasn't in with this lathe when I bought it. Had to buy this from Logan Actuator. It's an MT3 adapter. I put it in and set it. Those are gentle taps. So I'm going to put that in here, and that's how we're going to start this little exercise today about the tailstock. I have two of these blank drill arbors. They're MT2 to blank drill arbors, where you can machine these portions to whatever you need. They're soft, cylindrical portions. Nominal size, 1.024-ish is what they're supposed to be. Now, I should have bought MT3 to blank. A little bit of a story behind that. I was in the computer room and I looked at a reference rather than come out here and check, which was kind of stupid. But and in the long run on this project, I will probably buy two MT3 to blank arbors, which are a little bit bigger blanks. That doesn't matter for the purposes I'm going to use these for. But to start off, we're going to check these arbors for concentricity relative to the spindle and diameter, and record those numbers. So I'll start setting that up here with this one first. These MT2 to MT3 sleeves are items that I got with the Enco lathe. I got a lot of parts and tooling with the MT3 lathe. Now, interestingly enough, if you look at it, this sleeve is pretty nice looking, pretty pristine. This one looks pretty ugly. It's not really in bad shape, and it's a Cleveland twist drill sleeve, but it's had some rust and it has some nicks and dings. Now, I have done some experimenting with this last night previous to running this video. The run out that I was noticing was pretty bad, so I have taken both that sleeve I stuck in here, the adapter sleeve here, and this sleeve in particular, and massaged them a bit with my precision ground stones, which I bought from Steve at Shark River Machine. I'll try to put a reference in this down below on this video. He was one of the first people to offer precision ground stones after Robin Renzetti started talking about them. And we'll run some but I'll run these for run out with this, and we'll check the diameter, and I'll show you how I'm going to test these for setting up the see what I need to do to the tailstock and start building the adapters. So I had to run and make sure I have paper and pen and measuring instruments for this job. I'm going to start checking the run out and then the size of this arbor. Doesn't matter the orientation on this particular piece. Gently seat it. Bring this over, and I'm only using a thousandths reading 2-inch ish. Well, I hope, let me make sure you can see this. And I'm going to set this a little more out there. Let's set the 0 point. Yesterday, testing this, I was getting 35 thousandths of run out with this particular arbor in this particular sleeve. And today it's about 2 thousandths. So I'm not going to worry about 2 thousandths of run out and 2,000 in this situation. I'm not going to turn it to try to improve it. I'm not going to change anything. Obviously, stoning out the couple of little dings that I saw both on the sleeve from rough handling, the outer sleeve and the inner sleeve from rough handling and whatever, took care of all that. It's amazing. I may have to work over the other one because there was about 10 thousandths run out that I saw on that, but that may be taken care of here. So now we'll get this out of the way and record the size. And since I measured this before, I know I have to use the 1 to 2. And the clicker is pretty stiff on this. This is a cheap Chinese set, out of a cheap Chinese set. I've got a basically 0 to 12 set here. And that's reading 1.024 1.0241. I'll record that as Cleveland. 1.0241, which is probably more precision than I can actually use, but we'll go with that. Now the problem's going to be in this situation that it is kind of difficult to get this out of there. So sorry to step out of camera, but trying to get a calibrated knot going here. It's the first time I've been able to do this without banging things on the clear out, and I didn't use this yesterday, which is probably where some of the knocking came from. Now this one, the outer sleeve is smooth still, no nicks and dings, so we'll see how it looks. On its run out. Well, I see the battery ran out somewhere during the swap over. We're checking the run out on the second arbor. So try to get it near zero here and see how. And again, after cleaning up the dings in the adapter sleeve, we're at about 2/1000 run out. So the adapters are pretty good. Get this completely out of the way now and check the diameter here. I got to work on the micrometers, but I think that's about as good as I'm going to get. This one, one 1.02 3. Um, 1.0233. So let me set up something and we'll be right back. So I moved you a little bit and brought the tailstock that was with this lathe, that was in the cabinet under the tail end of the lathe. Despite being kind of beat up with the paint being a little bit beat up, it doesn't look like it was ever used, obviously, because if I bring it over with, this is the Cleveland twist drill arbor, sleeve and arbor, and I bring it up to touch, you can see there's quite an offset here. And that's the point of this exercise right now. We've got the two arbors that we know the dimension quite precisely. We know that there's no more than 2/1000 offset. And for the initial stages of what I'm wanting to do, which is figure out how big a spacer, how much spacing to build to raise this up, I don't need to know within 2/1000 until, you know, plus or minus 2/1000 right now, we could be up to 4/1000 off, but I don't need to know better than that until I'm close to final fitting. So now what we can do is come in here again with our 0 to 2 inch mic, get quite a bit of spacing. Now I did yesterday, I told you I messed around with this. I've got it pretty much by eye squared up horizontally. It's pretty much in line horizontally. And this method, using round arbors, to me is an idea I had that makes alignment easier than using two centers, because with points meeting, if I was trying to gauge where points were, it'd be, you know, what, hold a scale up there, it'd be kind of hard to get any precision out of that. And with this, you could actually measure your offset fairly closely in all the directions. Right now, all I'm worried about is vertical offset, so it's not going to be terrific. When I get to the end point, I may buy the proper arbors and make sure I face off so there's no bevels or very little bevel on each one, so that I have a good solid setup here. But right now, I get a pretty good reading, and that reading is 1.55 6 9, 1.5569. So I can write that down, and that'll, subtracting out the other two numbers, that'll give me a overly precise estimation of this difference. So see if you can see my calculation here. The last measurement we made was, the total was 1.5569. Now, from that, we have have to subtract the average, actually, of these two numbers. The difference between these two numbers, 1.02 from 41, 33 from 41 is 8. I just happen to be able to do that in my head. And so half of that is 4, so 1.0237 is the average diameter of those two arbor ends. So if we got 1.5569 minus 1.0237, we've got 2. 6 minus 3 is 3. 5 minus 2 is 3. 5 minus 0 is 5. 1 minus 0. So our height difference is 0.533. So if I'm going to make a spacer, I'm going to cut it to initially 0.53, probably shoot for 535. Or probably the initial starts 0.5354, 0.540. Write that so you can read it. 0.540. Then I can start working down in detail. This is the underside of the tailstock for the Logan lathe. And this is where I'm going to put the, I'm thinking about a 2-piece riser block system. This side's going to be relatively simple, just a rectangular piece. Now this is about 1 inch wide across here. It doesn't bear on the ways. The way part that it bears on isn't 1 inch wide, but I think I'll make the full 1 inch width here. This part over here where the V-groove is about 1.25 inches wide, but only somewhere in the V-groove does it bear. But I've got a piece of steel that's about 3/4 of an inch thick that I'm going to cut to 1.25 inches wide. Now I have on my for my horizontal mill a cutter that will cut this V-groove, and of course I've got straight cutters that can cut the groove up the center. This piece will be fairly simple to cut and fairly simple to attach. I'm planning on just attaching it with 2 dowel pins, somewhere here, and looking at this side, probably attach it with maybe small dowel pins on the outside to get the precision alignment. Since it mostly sits just on the tail, on the ways, getting the depth correct here. I've got plans in my head of how to do it, but I'm going to try to attract the attention of some of the better experienced people on the in machining YouTube community to hopefully give me some advice on how to set this up and whether I need to grind all these surfaces. I'm going to try to get the surface grinder. It may be a while that I'm working on this project while I get pieces of equipment in service to make some of the parts or surface grind it. Surface grind various features. But that's kind of where I'm sitting. I don't need to make a full piece. I'm not even sure I need to have the full length of either of these pieces precision fit. My current thought is to only fit or smooth or grind precision parts maybe 1.5 inches on each end. But I'm going to start making those parts soon. That gives you an idea what I'm looking at for the parts. Getting the V-groove depth should be not terribly difficult. This pops right off. So I can work with just the base here and put a dowel pin, not dowel pin, a gauge pin in here precision diameter measure off of here and get the exact depth, get a gauge pin depth and match that. Don't know if I need to grind that groove. Something I can set up somehow on the, might have to be buying more tooling. But that's what I'm up against. And it's just flat the wrong piece. And I don't think, well, the only thing I can find on Logan Actuator, I have the price lists for parts and stuff, and I can get this casting, the two castings from Logan Actuator for a 14-inch lathe tailstock, and I think they come to around $1,100 or $1,200. So making spacers for a 12-inch lathe seems like a very good approach. I haven't seen anything in eBay or anything like that. So that's where this project is going. I should have some other projects in the meantime, and we'll try to keep a steady flow of videos coming your way. Thanks a lot for watching.